Hi everyone, this is Math Analysis, section 2.6. So we are going to be talking about the transformation of functions, how the graph changes when we change the formula of something. So we're going to look at, first of all, we're going to suppose that C, so C is a number, and it's going to be bigger than 0. And we're going to look at a function, so some function f, and what happens if we add a number to a function. And what that does is it will shift the graph of f up C units. And we will do quite a few practice problems just so we can make sure that we understand all these. So adding a C value is going to take our regular value, which I like to think of this as remembering another name for f of x is y. So we're just going to take our y values and add whatever to that. Here, if we subtract that c, we are going to shift the graph, and I'm just going to abbreviate a little bit, down c units, so we can fit it all in there. Okay, so if we are outside or adding it to the outside of our functions, it's either up or down as it kind of specifies. When we work inside this function, so if you see a plus c inside the function, and when we go through examples, you'll be able to determine are we inside or outside. We're going to shift the graph left C units. It kind of works backwards. So we think going to the right would be for the plus, but if we're inside, we're going to be affecting the x values, and we're going to shift them opposite. So here we're going to be actually shifting the graph to the right, C units. Okay. These are kind of just some rules to kind of work with. If we have a negative on the outside, this is going to reflect or flip, whichever way you like to think of it, the graph along the x-axis, along the x-axis, because it's taking our y values and multiplying them by a negative, so it's going to flip it upside down. This negative on the inside will reflect the graph along the y-axis. So it's going to flip it this way, that way. Putting a c on the outside of the function does a couple of things. First of all, if it is bigger than 1, so like the number 2 or 4, it is going to stretch the graph vertically by a factor of c. I like to think of it as going to take our y values and multiply them by that c value. And so if this c is bigger than 1, we will see it being stretched this way, be pulled this way. If c is between 0 and 1, say a half, well, half of something is going to push it down, so it's going to kind of shrink it in this way. So it's going to shrink vertically. Okay. When we are inside our function, it works again inside. We're kind of working backwards. So if c is bigger than 1, we actually shrink, horizontally by a factor of 1 over c. So if c is like the number 2, we're going to be shrinking it in half. Everything's going to come in halfway. If it's between 0 and 1, we're going to stretch horizontally by a factor of 1 over c. And this looks kind of funny because you're thinking fraction, fraction, but thinking this as being a half, if c were a half, we would stretch it by a factor of 1 over this, so 1 over this would actually be 2, so we'd be stretching it out twice as far. Here, if c were 3, we'd be shrinking it by a factor of a third, so we'd be bringing it in 1/3. This one is something that we will see a little bit more in detail. Well, we'll see all of these in detail again later, but this one really makes more sense when we start talking about our trig functions, something that is periodic. We'll see how that c affects things a little bit more in detail there. Okay, let's go through some specific examples so we can see these shifts moving. So let's start with a function. And I'm just going to draw a function, a simple looking thing, so kind of make some points here. And we're going to do, let's see, go here, and we'll go up here, so kind of a straight line. And let's kind of make it a little bit flatter. So here, kind of go that way, and then we'll do this there. It's kind of a, I don't know, so there's my function. There's my function f. Okay, so this would be the point, well, this is 1, 4. This would be 3, 3. Yeah, and this is going to be 3, 4, 5, 2. This is 0, 2, and this is -2, 2. Just so we have some points in there so we can kind of mess with those. And let's look at y equals f of x plus 2 minus 3. And let's first of all talk about what's going to happen, and then we will actually draw it. Now, thinking about how things work and the order of operations says we're going to start inside our parentheses. So we're going to start with this plus 2 on the inside. So this plus 2 on the inside is going to, it's affecting that x value. It's going to shift things horizontally speaking, and we're going to kind of work backwards. So it's going to shift things to the left 2 units. Okay? Or you can think about these x values. We're going to take those x values and subtract 2 from them to get a new x value. This minus 3 is going to then take those values, and we're going to shift down 3 units. So we're going to take our y's and subtract 3 so to make it go down. So, and we can do these to these points if we want to. And some students find that easier to do. So they'll take these points and they will subtract 2 from the x, and then they'll subtract 3 from the y, and so then they'd get this. So here's our original points. Throw them in here. And my 5, 2. And then they transfer them through those changes. And they're going to subtract 2. So that's going to be a minus 4. And then subtracting 3, minus 1. Minus 2, minus 1. Minus 1, 1. I have to think here. We're subtracting 2, subtracting 2, subtracting 3. Subtracting 2, subtracting 3. Okay? And then we can plot those points, the new ones. Okay, so -4, -1, -2, -1, -1, 1, whoops, 1, sorry, missed it, and then 1, 0, and then 3, -1. There we go. Or what we could have done is moved everything over 2. So I could have done, get some colors here. If I move everything over 2 units, this one's going to go here. This point will go to here, so I'll make some little stars. This one will go here. This one moving over 2 puts it here. This one moving over 2 puts it here. And then we need to go down 3. So down 3. This guy, down 3. Down 3. And then down 3. And then connecting my new stars. I don't know if you can see that. Probably not real well. Okay, so whatever method makes more sense to you, feel free to do that. I do find a lot of students do like this point idea because it helps them. Some people like to do the shifts. Some people will do them all at once. Some people do baby steps, one little thing at a time. You need to find a method that works for you. Okay, I like to work with problems that, you know, start with a graph that you can't just plug into a graphing utility of some sort and look it out. But you can practice these. Graph, take a function that we know, and I'll do one in after a little bit, and move it, and then you can graph and check with your graphing utility as well. And there's lots of graphing programs out on the internet that can graph things for you. Okay, but I want to work with this guy again, and maybe I'll get a different color so that we can see. This one shows up pretty good, yeah. And I don't know if it looks different though, but it is purple. We'll see. And let's graph y equals, let's do a negative f of x and then plus 2. Okay, so we're going to graph this one. So again, order of operations says do inside parentheses first. We have nothing going on there. And then we do any multiplying before we would do any adding and subtracting. So we're going to have to do this negative here first. And this negative on the outside, what that's going to do is it's going to flip it vertically. So flip vertically along that x-axis. For it to happen on a point, we're going to take that y value, and to make it flip is we're going to multiply by a -1. So every y is going to be multiplied by -1, and that'll cause it to become from positive to go negative, and negative to come up and go positive. And then we have to take care of that plus 2, and that is going to move our graph up 2 units. And it does just take a long time or a while to get these ideas down. So that first page that we had written, all those little properties, you know, the adding moves it up, the subtracting on the outside moves it down, all of those things, I have been teaching this for a long time, so they are instilled in my brain. It's kind of like we stop at a red light, we go on a green light. That's how much I know these things. So you need to get to that point somehow. Kind of drill them into your head. And to me, I like to think of this as my y value. So my y value is being multiplied by something, and then we're going to add something. When I'm inside, things are a little bit different, and it is a little bit harder to remember those. But I think inside is weird, and it works backwards. That's what I think through. So here I'm going to, again, I like to do this method with the points. It just is an easy way to do these problems. So I'm going to take that -2 out my list again, and we will see these things happening. And I'm going to actually do it in 2 steps because these both affect my y's, and if I try to do them at the same time, I'm going to make a mistake. So I'm going to do the negative part first because we multiply first. So that's going to take all of those y values and make them negative. Okay, if I were doing that up here, we're going to be flipping it down. So these points are going to come down here. Kind of draw them in here. This 1, 4 is going to go down to 1, negative 4. My 3, 3. And that 5, negative 2. So it'll look something like this. So that's just the flipping. So that's just this negative upside, that negative outside the function. One thing I do want to also mention, when you are doing these transformations, the original shape is not going to change dramatically. And what I mean by that is we have 3 straight line pieces. You will always end up with 3 straight line pieces. We have a point here. You will have a point. You will have a point or a corner there as well. Through these transformations, you cannot turn a straight line into a curved line. So they will remain straight if they started out straight, and you'll have corners where you had corners. You can get them steeper and less steep, but you can't change the overall shape. They'll look very similar. It's kind of like just changing your axes possibly. Okay, we took care of that negative, and now I'm going to take care of this plus 2. So again, this plus 2 is going to move everything up. So I kind of write myself little notes. I will say flip vertically, so that means this is what I have to do. Moving up means I'm going to take my y values, because that's up and down, and I'm going to add 2 to those. So I'm going to add 2 to the y's, 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 and try not to make mistakes, and adding 2 to the y. Okay, so I'm going to put that, I'll get another color. I'm going to go back and put that up on my original graph. So you can see that it did go up. So negative 2, 0, 0, 0, 1, negative 2, 3, negative 1, and 5, 0. And then connect your dots. Okay, there we go. So again, 3 straight lines and 2 corners. Yes, it's flipped upside down and shifted, but the basic shape stayed the same. All right, I think I can do one more on this video before stopping. If I don't make it too difficult. I want to stay with the same graph, so my same original graph. I mean, why not?